Assalamualaikum dan salam sejahtera everyone. Today we will do a presentation about crystalline imperfection. We are from group 4, consists of me, Ijam, Putri and Hasni. To begin with, planar defect is the one type of the crystalline imperfection. It can be defined as the fact that occurs over a flat, two-dimensional area in a crystal. It happens when the normal atomic arrangement is disturbed along a plane, which can affect the material properties such as strength and conductivity. Such as free surface. Free surface means planar defect where the crystal lattice ends at the surface of material, causing surface atom to be not fully bonded. Free surface effect. First, surface atom have higher energy. Second, increases chemical reactivity. Example, free surface. Catalyst in chemical reaction and the surface of a metal exposed to air is a free surface.
A stacking fault is a type of planar defect that occurs when the normal stacking sequence of atomic planes in a crystal is disrupted. In a perfect crystal, atoms are arranged in regular repeating layers. For example, in closed-packed crystal structures, the normal stacking sequence is ABC ABC or AB AB. Stacking faults happen when the sequence is interrupted or changed, such as ABC AB ABC. This interruption creates an imperfection along a plane in the crystal. Stacking faults can occur due to imperfect crystal growth, and it is also can occur due to plastic formation when stress is applied to a material. And lastly, it can occur due to the presence and movement of dislocation within the crystal. Stacking faults affect the mechanical properties such as strength and ductility. It also affects the dislocation movement, influencing how a material performs. And lastly, physical behavior of the material, especially in metals, are also affected. Stacking faults are commonly found in metals like aluminum, copper, and steel. It also can be found in materials with a phase center cubic FCC crystal structure. In the conclusion, the stacking fault is a planar defect caused by a disruption in the stacking sequence of atomic layers, and it plays an important role in determining the mechanical properties in crystalline materials.
Hello everyone, today I'm going to talk about point defects. Point defects are imperfections that happen at a single point or atomic position in a crystal lattice. In simple words, point defects happen when an atom is missing or when there is an extra atom in the structure. Even though these effects are very small, they can greatly influence how a material behaves. First of all, I will explain about vacancy defect. A vacancy defect happens when an atom is missing from its original position in the crystal lattice. This usually happens during crystal formation or when the material is heated to high temperature, causing atoms to move out of place. So this is the effects of vacancy defect. First, the density of the material slightly decreases because some atoms are missing. Second, atoms can move more easily, so atomic diffusion increases. Third, the material is more likely to experience creep, especially at high temperature. And lastly, the mechanical properties such as strength and durability can be affected. I will give you a simple example. Imagine there is an empty seat in a classroom. Since the seat is missing, we can move around more easily. In the same way, when an atom is missing a crystal, the surrounding atoms can move more freely.
Next, I will explain about interstitial defect, which is one type of point defect. An interstitial defect occurs when an extra atom squeezes into the empty spaces between the normal atoms in a crystal structure. Usually, only small atoms can cause this defect because only small atoms can fit into these tiny spaces. This interstitial defect gives several effects on the material. First, the crystal structure becomes distorted and stressed because the extra atom pushes the surrounding atoms. Second, the material becomes stronger and harder. However, at the same time, it becomes less ductile, which means it is easier to break. A simple example is like someone standing in a narrow aisle. When an extra person stands there, movement becomes restricted. Similarly, the extra atom restricts the movement of atoms in the crystal.
In conclusion, real crystals are not perfect and always contain defects. Planar defects such as free surfaces and stacking affect the surface behavior and the strength of materials. Point defects, including vacancies and interstitial, disturb the atomic arrangements and influence properties like diffusion, hardness, and conductivity. Overall, these defects play an important role in determining the mechanical, chemical, and electrical properties of materials. That's all from us. Thank you.